Okay, algebra students, we're going to go ahead and we're going to talk about the second half of chapter 8. So we worked on graphing quadratics, and now we're going to solve quadratics. And so our original quadratic function looked like y equals ax squared plus bx plus c. Now we're going to have a related quadratic equation where instead of a y, we're going to have a 0 in that spot. And so again, just replacing y with 0 to get this equation, ax squared plus bx plus c equals 0. And our 0 can be on either side, it really doesn't matter. But a lot of people like to see it with the ax squared plus bx plus c on this side and the 0 on that side. But again, it's the exact same thing, it doesn't really matter. Now, one of our methods to solve a quadratic equation in standard form is to graph the function. So we're going to graph the related equation, y equals this, and we're going to find the x values where y equals 0. And so in other words, we're really just finding those zeros that we are finding in the first half of the chapter. So the zeros where it crosses our x-axis. And recall that in our quadratic function, we could have it crosses in 2 spots, 1 spot, or no spots whatsoever. So we're going to go ahead and take a look at some of these related problems. So we have solve negative 2x squared plus 4x plus 6 equals 0. So we're going to solve this equation. Luckily, it's already graphed for us, so now we're going to look for where the zeros are. Here's a 0 and here's a 0. So that means the answer to the equation is x equals negative 1 and x equals 3. And there's our answer. And so on the next problem, we're going to solve x squared minus 4x plus 7 equals 0. And we're looking to see where it crosses our x-axis. It does not, so there is no solution. And this is technically no real solution, because as we get into higher levels of math, we're going to see that there are actually imaginary solutions to these answers. But at this point in time, we have not talked about imaginary numbers and how that fits into things. So we just have no real solution. And then in our next one, let's see, we're going to solve the equation negative x squared plus 6x minus 9 equals 0. And when we look at that, it crosses right here, so that means my answer is x equals 3. And then our last one, we're going to solve x squared minus 8x plus 7 equals 0. So we're looking, where does it cross? Here and here, which means my answer to the equation is x equals 1 and x equals 7. And those are our answers. So that's the easy way, when they give you a graph and just being able to identify what are they really asking, so what is the answer to my equation. But you're not always going to have a graph. So here we're going to take a look at, what do we do if there's not a graph? Well, we create our own graph. How do we create our graph? Well, we find the vertex by starting off x equals negative b over 2a, where this is our a and this is our b. So x equals negative 12 over 2 times 2, which is positive 12 over 4, which gives us 3. And then we're going to go find our y by y equals 2 times 3 squared minus 12 times 3 plus 18. So this is going to give us 3 squared is 9, 2 times 9 is 18, minus 12 times 3 is 36, plus 18. This gives us negative 18 plus 18, which gives us 0. So our vertex is at 3, 0. So 3, 0. And then we have a pattern of change. So if our a value is 2, it's going to be 1 times 2, 3 times 2, 5 times 2, and then we graph from here. So up 2 over 2, or over 1, up 6 over 1. There's our graph. And now they want to know, what is the answer to our equation? What is our actual answer? And our answer is x equals 3. So now we're going to do the same thing on the next problem. We have our a, we have our b. So x equals negative b over 2a. Negative 8 over 2 is negative 4, and we're going to plug that in. So y equals negative 4 squared plus 8 times negative 4 plus 16. So what is that? 16. Oh, I forgot an 8. Minus 32 plus 16. So negative 16 plus 16 gives us 0. So we're graphing at negative 4 is 0. Negative 4 is 0. And then our pattern of change is 1, 3, 5, 7. Why? Because our number is a, and 1 times 1 is 1, 3 times 1, so on and so forth. So up 1 over 1, up 1 over 1, 1, 2, 3, 1, 2, 3, and then 5. And there's our graph. And then once we have it graphed, we want to know what is our actual answer. Where does it touch the x-axis? And that's at negative 4. So we've seen several different types of answers. We have 2 answers on this problem. On number 1, we have no answers on number 2, 1 answer on number 3, 2 answers on number 4. And then as we move to number 5, we have 1 answer, and number 6 has 1 answer. So we always have the option of no answers, 1 answer, or 2 answers. So let's move to our next problem. We're going to go ahead and our a is 1, our b is 6, so x equals negative b over 2 times a. So negative 6 over 2, which gives us negative 3. We then plug that in, so y equals negative 3 squared plus 6 times negative 3 plus 10. So this gives us 9 minus 18 plus 10. Negative 9 plus 10 gives me 1. So my vertex is at negative 3, 1. So negative 3, 1. And then my pattern of change is 1 times 1, 3 times 1, 5 times 1, and 7 times 1. So up 1 over 1, up 3 over 1, up 5 over 1. And again, looking at where it crosses our x-axis. And it does not cross our x-axis, so there is no solution. And again, this is really no real solution, but for our circumstances, we can just write no solution because we haven't talked about any other types of solutions. Okay, for our next one, we're going to go ahead and rewrite this real quick. This is negative x squared plus no x plus 4. So that way, as we do our a and b, we have those values. X equals negative b over 2 times a. And this just gives me an x value of 0. We now plug in y equals negative 0 squared plus 4. So 0 squared is 0 plus 4 is 4. So our vertex is at 0, 4. 0, 4. And then our pattern of change, since that's a negative 1, so negative 1 times 1, negative 1 times 3, negative 1 times 5, negative 1 times 7. So I go down 1 over 1, down 3 over 1, and then down 5 over 1. And so now we look to see our answer. Where does it cross this x-axis? It looks like negative 2 and 2. So our answer is x equals negative 2 and 2. And that's what we're going to be working on in class.